Hello, boys and girls.
Children of all ages.
Welcome to K-Cubed Calculus Curriculum. So the first thing we are going to be discussing today is the behavior of f prime. X-intercept on f prime, then this tells you where there is a relative maximum or minimum on f. And if you go from negative y values on f prime to positive y values, then that tells you where there's a relative minimum. And if you go from positive y values to negative y values, that tells you where there is a relative maximum on the function f. And then for f prime, if you have it bouncing off the x-axis where it does not cross over the x-axis, then that tells you where there's a point of inflection on f of x. So when we were trying to go from f prime to f, there are multiple different graphs due to the fact that there is a rule which all constants turn to 0 when you take the derivative of a function. So if we look at both of these functions, one is shifted up 7 and one is shifted down 107, but when we take the derivative of both of these, they have the same derivative. But one is shifted up 7, one's down 107. So it doesn't matter what that constant is, and it could basically be moved up or down however much you want and still have the same f prime graph.
Okay, so we know that wherever there's a point of inflection on f of x, there will be an x-intercept on f double prime of x, and there will also be a maximum and minimum on f prime of x. Okay, as you can see here, this is a maximum, this is a point of inflection, and right here it crosses the x-axis. And then same here, here, and here. And we also know that when there is a point of inflection, this will be a maximum or minimum on f prime of x, which means that it has a derivative of 0, which means that the y value for f double prime of x will be 0.
So f double prime and f prime have a similar relationship to how f and f prime have with the x-intercepts and the maximums and minimums. So as you can see, as f prime is approaching a maximum, then it's increasing towards that maximum, then you know f double prime is positive y values leading to the x-intercept, because then it changes to negative. So anywhere where there's a maximum on f prime is where there's an x-intercept on f double prime. So as you can see here, it is going from increasing to decreasing, so positive to negative, and then where there's a minimum, it is going from negative to positive, so there's your x-intercept, and there's your minimum. And then the third is this relative maximum right here, where it is going from increasing to decreasing, so once again, double prime is going from positive to negative. Alright, so when we are looking at f to f prime, we can tell that anytime when f is decreasing, then f prime is below the x-axis due to a negative slope giving you negative y values on f prime. To determine the behavior of whether f double prime is above or below the axis, you look to see where f prime is increasing or where f prime is decreasing. And if f prime is increasing, then that means f double prime is going to be above the x-axis. And if f prime is decreasing, then that means f double prime will be below the x-axis. And to know how far away f double prime is from the x-axis, you take the absolute value of f prime, which would give you the slope at a point on f double prime. Your slope at a certain point on f prime is then your y value for f double prime.
We know that when f prime of x is increasing, then f of x will be concave up, but when f prime of x is decreasing, f of x will be concave down. Similarly, when f prime of x is increasing, f double prime of x will be positive, but when f prime of x is decreasing, then f double prime of x will be negative. This shows that there's a relationship between f double prime of x and f of x, because when f double prime of x is positive, f of x will be concave up, and when f double prime of x is negative, f of x will be concave down.